Hello everyone, my name is Kamal Human. Welcome to this lecture on thermal energy storage, latent and thermochemical energy storages. The goal of this video is to understand why we need to store energy, to understand how phase change materials and thermochemical materials work and how they can be used for energy storage. So why do we need to store energy? In many applications as engineers, we prefer not to work with moving targets. The devices we design prefer a steady operating environment, so we need to provide this stability through buffer or storage media. With our ever-increasing interest in renewables, we need to store energy even more, mainly because most renewable energy sources are intermittent in nature. Wind blows and sun shines on a certain pattern, which we cannot control, though we can predict those patterns. Therefore, we need to be prepared to provide thermal stability for our devices. Also, we can generate more than we need at times. As opposed to curtailment, we can store this excess energy and use it later when we need it more. How to store energy depends on what form of energy we want to store. Some examples are listed here. We were taught how the ice melts or water boils. Tap water at room temperature is poured in a kettle, well-insulated kettle. If we heat it, the water temperature increases. If we keep heating it, the temperature remains constant, but the heat added to the kettle is spent on phase change. If we keep heating the steam in the kettle and keep heating it, then we will have steam at higher temperatures, or superheated steam as we call it. So we can go to the right or the left of this plot if we want to add heat or remove heat from the same kettle as we talked about. Similarly, we can use different materials, could be organic, inorganic, or eutectic mixtures. These materials exhibit similar phase change behaviors at different temperatures. You can see that water freezes, for instance, under atmospheric pressure at 0, and seen different materials offer different set points, if you may call it. Over this set point, heat is transferred to or from, but the material temperature does not change. This is the buffer effect we just talked about. We can also use a chemical reaction to our benefit. Certain reactions need heat to happen and would release heat if the reaction is reversed. We can then thermally charge or discharge a system if the heat of reaction is released or added to the system for the reaction to occur. We like to work with cheap, inert and benign working fluids. To our preference is to work with air or water by as much as we can. The question is always about how long we want to store the heat for. Seasonal storage versus storing it for a couple of minutes, they need different design considerations. Some questions to keep in mind are listed here if you want to further develop storage applications to future. To recap, we have discussed the importance of energy storage and given some examples of different types of energy storage. We have seen two types of thermal energy storages, PCMs and TCMs, and finally we covered the way forward for energy storage in the future and how we can use it.